There are three versions of the controller in front of you. Version rear, version medium, version well done. Let's look at the rear version. You can connect external buttons or triggers for start, stop commands and direction changes. Connect limit sensors, and connect a stepper motor driver using step, DR signals. Let's connect it. For this, you'll need a standard Type-C 5 volts cable. Note that the step, DR signals in this controller are 5 volts. We recommend checking your motor driver to ensure it accepts these signals at 5 volts. Now you see an approximate table of motor types this version of the controller can work with. Now let's look at the medium version of the controller. The difference from the rear version is that it includes a stepper motor driver. A motor driver is also included in the well done version. You can adjust the current for your stepper motor, and set the microstep for the motor. For power, there is an input for 20 to 48 volts DC. There is also a port for connecting external sensors and triggers. External control buttons and a stepper motor can be connected too. There is also a version with a driver that supports motor encoder feedback, known as the closed-loop system. Let's connect 48 volts to the device. For the medium version controller, you will also need an external power supply of 24 to 48 volts and, of course, a stepper motor. Now you see an approximate table of motor types this version of the controller can work with. Let's look at the top version. Well done. You now see the version with a driver that has feedback from the stepper motor encoder. As you can see, the well done version includes the medium version and also has a built-in 36-volt 5 amperes power supply. This version is ideal for NEMA 23 motors. You can also configure it to work with NEMA 17 and NEMA 34 motors. Let's connect this one. To summarize, the rear version is perfect for simple setups requiring external motor drivers. The medium version includes an integrated stepper motor driver, offering more convenience. The well-done version features a built-in power supply ideal for advanced applications. Choose the version that best fits your needs and start optimizing your CNC projects today. After turning on the controller, we will switch to the speed layout. In this layout, we have the ability to control the stepper motor. You can manually adjust the direction of the motor using the controls. Additionally, the speed of movement can be modified manually, even while the motor is running. This provides precise control over the motor's operation. Now we activate the physical sensors. The controller is compatible with normal closed 2-pin sensors. For example, the ones you see on the screen. To activate them, we go to the main menu, navigate to the Settings section, then to General Settings, and activate the sensors by pressing the Input Sensors. We return to the speed layout, and as you can see, the sensors are now active. To move off an active sensor, simply press the Limit Override button on the screen, change the motor's direction, and press Start. Now I will activate the button, Go to Sensor. In this mode, the motor will move towards the sensor. Once the sensor is activated, the motor will stop and then move away in the opposite direction. The distance the motor should move back from the sensor can be specified in Settings, Parking, Back Off. I will set the value to 0. Let's return to the speed layout and start the motor. As you can see, the motor moves towards the sensor and then moves away in the opposite direction. For demonstration purposes, let's set the back off parameter to 50 mm. Now I will activate the loop mode. In this mode, the motor will move cyclically between two end sensors until it is stopped by pressing the stop button. To fine-tune the movement in the cycle, we can adjust several parameters: the speed during movement between sensors, and the speed at which the motor moves away from the sensor. These speed parameters are found in the Settings, Parking section. Now, I will set the same speed parameter for all. Let's set the speed to 100 mm per minute and observe how smoothly the motor moves. We can also adjust the motor's acceleration and braking. For example, I will set the parameters so that the acceleration is 10 times faster than the braking. This can be done in the Settings, General, Acceleration, Deceleration section. Let's set the speed and see how this configuration works. Now, we will create a difference where the acceleration is 100 times faster than the braking and observe how this setup looks. In the speed layout, you can connect external control buttons for functions like start, stop, or changing the direction of movement. The rear controllers section has 4 pins for connecting buttons or external triggers to execute commands. It operates at 5 volts. In the medium version of the controller, you can also connect external buttons or triggers. Now, let's connect the buttons to the "well done" version of the controller and see how it works. Now we will switch to the coordinate layout. In this mode, you can specify the exact distance for the motor to move. To find a consistent 0 point, you need to perform parking for your device. And now the slider is positioned at coordinate 0. Now you can specify the distance your device needs to move. This can be either a linear coordinate or a circular one. You can also enter a negative coordinate if needed. By pressing the Go to 0 button, your device will return to the 0 coordinate. You can set a new 0 coordinate wherever you like. To do this, press the Set as 0 button. Now I am moving the device 10 mm relative to the new 0 coordinate. You can also change the speed of your device's movement. In this layout, you can also connect an external button or trigger for the start, stop function. In the Saved Values section, you can save your presets for linear or circular distances. To edit or update a cell, switch to Edit mode by pressing the Edit button. Select the cell and enter the new value. To exit Edit mode, press the Run button. Now you can move your device to the coordinates you set. You can also save negative coordinate values. Let's switch to the distance layout. In this layout, You can specify the distance you need your device to move. You can also set a delay between movements if needed. The delay is specified in milliseconds. 1 second is 1000 milliseconds. After pressing the Go button, the device will move once to the specified distance. You can also park the device to work from your zero coordinate. When activating the loop mode, you can specify how many times you want the device to move the specified distance. You can also specify the speed at which the movements should be made. In the distance layout, you can set up both single movements and cycles of repeated movements. You can also set a new zero coordinate by pressing the Set as Zero button. Or return the device to the zero coordinate by pressing the Go to Zero button. In this layout, you can also connect an external button or trigger for the start/stop function. Let's go to the settings. The first section is General. Here you can choose the measurement system, either millimeters or inches. You can also set it to circular movement. The system calculates everything in units. What a unit represents is up to you. It can be a degree or a unit of length. Here you can also activate sensors or reverse the ruler scale from left to right or invert the motor's movement. I recommend inverting the motor's movement on the driver or by changing the wiring connections. Here you can also specify how many pulses need to be sent to the motor driver for movement by 1 unit. Specify the maximum speed of your device. You can also set the motor's acceleration and deceleration during start and stop. By setting different values, you can achieve a soft start or a soft stop. In the Calibrate section, you can adjust the precision of your device's movement. For this, specify the distance to be traveled and the speed at which it should be done. Make initial measurements with an external tool. Press the Calibrate button and wait for the device to move. Take final measurements. In the distance measured field, enter the actual movement value. Press Save. The pulse value will be recorded and you can check it in the General section. Your device is now calibrated and ready to work. After setting the number of pulses, you can, if needed, configure your working area. To do this, check if the limit sensors are activated in the General section. Press Auto Discovery and wait for your device to automatically measure the working area. You can always change the working values by simply entering the required value in the Start-Stop coordinate cell. Device parking setup. Before starting, you must activate the limit sensors in the General section. After activating the sensor, you can start setting the parking parameters. The first parameter is to specify in which direction you need to park your device. In the homing speed up and homing speed down cells, you can specify the speed at which your device will move when executing the parking command towards the limit sensor and the speed at which it will move away from it. Usually, the second parameter is slower. The zeroing of the position occurs precisely when the device moves away from the sensor at a low speed. In the back-off parameter, you can specify how far your device needs to move away from the sensor. For demonstration purposes, I will set this parameter to 50 mm. This position of the device will be considered your zero working coordinate. If you need this value to be different from 0, you can specify your offset in the sensor's coordinate unit cell. For demonstration, I will set this parameter to 50 mm. You can also set this parameter to a negative value if needed. And as you can see, the device moved away from the sensor by 10 mm and now indicates that it is at 50 mm.